Okay, so there's one more thing before we look at the force due to friction. That's something called the normal force. So again, we did see this with when we looked at free body diagrams. So just a reminder, a normal force is a support force, and it's always perpendicular to the surface, so it's in contact. So it says a 25 kilogram object rests on the table. What is the normal force? So if we have a table, here's my table. We have an object, and that object is 25 kilograms. We know that there's the force of gravity going downwards. However, if this object is not moving, and we know, just look at, you're probably using a computer right now, the computer's not falling downwards, right? But there's a force of gravity. There must be something balancing that force of gravity, and that is our normal force. The table is preventing that object from falling through the table, and it must be equal and opposite. So we call this the normal force. So force of gravity is down. If it's stationary, it means the net force must be 0. Therefore, whatever force downwards must be matched by an upward force. So what we can say is the sum of the forces in the y direction must be 0 because it's not accelerating up or down. The forces that make up the forces in the y direction, you see the normal force is up, the force of gravity is down, therefore normal force is equal to force of gravity. So if we solve for our force of gravity, which is just mass times gravity, 25 kilograms times 9.81, we get a normal force is 250 newtons. Okay. Next up is our force due to friction. So this is our equation. You don't have to memorize it, but it's a pretty straightforward one. Force of friction, the subscript F to denote friction is a force, so it's measured in newtons. This is the symbol mu. It stands for coefficient of friction. So basically every different surface has a different coefficient of friction. Now we've all experienced this before. Some forces are very slippery. So slippery surfaces would have a low coefficient of friction. Other ones, it's very like sticky or tacky, or it's like that rough surface. Those ones have high. So for example, a car tire, right? They have a very high. The coefficient of friction is very big because you don't want your car sliding around. Okay. So this value is just always going to be given to us, or we have to solve for it. But generally speaking, you can just look up. You can Google coefficient of friction, and you can find a lookup table for different things like wood on wood, wood on metal, etc. And what we'll notice right here is the force of friction also depends on the normal force. So basically what's happening, if you have an object on a surface, that friction, so if we zoom in to an object, basically what happens, like the surface, if you zoom in, and no surface is perfectly flat, it's actually more like bumpy. Right? So the greater that normal force is, basically the more it's being squished together, the harder it would be to push something forward. So the greater the normal force we know, the heavier something is, the harder it is to slide it. Okay, so basically if there's that more compression force between the two, it's going to have a greater friction force. So there's actually two types of friction. There's static friction, and then there's kinetic friction. So static friction is the force that keeps an object from sliding. And kinetic friction is the force that requires to keep something moving. How it turns out is static friction is always bigger than kinetic friction. Think of how that works. If we look back at this diagram right here. So first of all, I say when objects, they kind of like, the grooves in the objects kind of rest within each other. Right, so it's kind of like Lego. They kind of like lock in place when they're at rest. But it's not perfectly fitting Lego, so it's not gonna be like completely stuck together. But it's kind of, you have some grooves that are kind of fitting with other grooves. And what happens is it gets always a little harder to get going. But once it starts moving, it's now those grooves are kind of like pressing the top, so it's no longer kind of interlocking as much. It's kind of like just sliding along that surface without the grooves kind of wedging in between each other. And when it comes to rest, it'll kind of settle in again. So what it works out is the static friction is always bigger than the kinetic friction. It's harder to get something moving than it is to keep something moving.